Identifying a need. Technical objects are objects designed and built by man to respond to all our needs. Yes, it's true. There are sometimes needs that are not satisfied. And even after having searched, we don't always find a technical object that efficiently responds to this need. We are now faced with a technological problem. Analysis of the technological problem. The solution to this problem starts with the design of a new object, a job dedicated to specialists. Design people, be they designers, engineers, architects, or others, are professionals who are always on the lookout for new technological problems to be solved. Designers will initially analyze the technological problem. This is the first stage of design. They become familiar with the context and note all the data relevant to the problem. They formulate the problem, then deduce from this analysis the function that the technical object must fulfill. This is also the moment to identify the usage and fabrication conditions for the object. These are criteria that the technical object must satisfy. It's on the basis of these elements that the designer and the client agree and launch the project. These elements are gathered into a document containing the technical specifications. This document is central to the agreement that binds the client and the designers. Principal study. The designers may now start to make the most of their ingenuity. They will first try to reproduce or visualize the function that the object must fulfill, initially in a very rudimentary way. It's at this time that they will begin to use technological languages. Technological languages are various types of drawings carried out in order to communicate, explain, and describe ideas and solutions. The first question to be asked is, according to which principles will the object function? Okay. In our case, we're talking about mechanical principles. That's because the function we're seeking is to apply a mechanical force on an object. That is, to lean on a piece of paper to maintain it in place. Another problem could have implicated electronic, optical, computer, or other principles. So, the designers will look among the basic mechanical principles for those that could be applied to the object. Note that the designers will often carry out their drawings by hand for more speed, especially at the beginning of the process. This is the sketching technique. To make it easier to understand, they use different colors to differentiate each part and show the interior of each one in the form of sections. For the same reason, they also add all useful information such as the forces of action, the names of their parts, their movements, things like that. What we've just described are the characteristics of a principles diagram. A diagram is a simplified representation whose objective is understanding. Diagrams are a true language used for sharing between designers. At the same time, the designers analyze existing objects whose function is similar. This allows them to observe and understand certain principles in action. In this way, the designers discover the principle that logically allows the desired function to be fulfilled, the retained principle. The construction study. The construction study looks to understand how the object will be made. Practically, this study is often done simultaneously with the principal study, but shh, don't tell anyone. Of course, several problems remain to be resolved. Many ideas will be debated. The designers go from one language to another depending on their needs or what they have to communicate. At this stage, for instance, when the time comes to explain a mechanical solution, one may choose to represent it in the form of a diagram. When the time comes to put the accent on assembly details, another may choose to execute a basic technical drawing. Or, to give an overview of the appearance of an object, they may opt for illustration. Okay, for the time being, let us consider only the diagram. This is a simplified representation whose objective is understanding. A diagram won't necessarily show the true appearance of an object, but instead brings it down to the essentials. In design, we make the distinction between two types of diagrams. A principles diagram shows how the object functions. By symbols, the general characteristics are shown: forces of action, movements, guides, and links between parts. While a construction diagram defines construction solutions, which show the shape of the parts, the way they're linked, some of the dimensions, and often even the materials to be used. The solutions debated among the designers are regularly submitted to the criteria set out in the specifications booklet at the start. If a criterion is not respected, the designers will not hesitate to go back to the drawing board to reevaluate certain solutions. And they will do so until they have defined an object that responds to all the criteria. This is the preliminary concept. Prototyping. A crucial stage in the design of a technical object is that in which the prototypes are made. Prototypes are the first examples of a technical object. They allow for construction solutions to be tested to verify if the object fulfills its functions well. In fact, designers often make prototypes at the same time as they study construction principles and solutions. Before building a first prototype, the designers will precisely draw each of the parts. They prepare preliminary technical drawings. A technical drawing defines the object more rigorously with precise shapes and dimensions according to well-established conventions. For example, the lines that show the visible outlines, the hidden edges, the dimension lines, the axis lines, and others use very specific shapes and widths. The precision and depth of detail in this preparation depends upon the complexity of the object. It will be in greater detail, for instance, if the designers are not carrying out the fabrication of the prototype themselves. Then, it may even become necessary to prepare instructions to follow. In the workshop, designers use various tools and machines to make a first prototype. Testing allows them to confirm that the object, that it's necessary to review certain construction principles or solutions and to make a second prototype. In fact, they will make as many prototypes as are necessary until they obtain a fully functional one, the final prototype. Validating the concept. It is now time to have the client validate the solutions proposed by the designers. They will prepare careful drawings to help the client fully understand the preliminary concept. These are realistic illustrations called renderings, which are sometimes also accompanied by diagrams. An illustration's objective is to give a realistic visual overview of its appearance, its texture, its tone, its style, its aesthetics. The client becomes familiar with the solutions suggested by the designers. In case of disagreement, they will have to revisit their concept. If the client is satisfied with all the proposed solutions, the concept is validated. Producing the final technical drawings. The experimentation that took place with the prototypes will have allowed us to specify the shape of the object in its slightest details. The final technical drawings will be carried out in light of this experimentation. It's from these drawings that the object will be able to be mass-produced, to launch production. The draftsman must show great rigor and know-how. His abilities will allow him to represent the object without any ambiguity in all its facets. He will generally represent the object and its parts according to complementary views: front, top, right, left, back, and bottom views. This type of representation is called multi-view orthogonal projection. A little further along, we'll see other types of projections. These parts are identified in the nomenclature, the dimensions specified by dimension lines. Drawings will show the entire object composed of all its parts. These are assembly drawings. When an object is very complex, there are sometimes also subassembly drawings. Other drawings will only show a single part or portion of the object. These are detailed drawings. They may also show all of the disassembled parts in a single view, an exploded view, or show the inside of a part, a section view. Finally, each drawing is clearly identified and numbered as being part of a set in a box called the cartridge. These days, we see draftsmen using computer software to carry out technical drawings. In certain cases, they can even create a three-dimensional model that will be directly interpreted by the machines that will manufacture the object. It's just crazy. Excuse me. But let us not confuse 3D computer-aided design models with 3D drawings or projections that are a way of representing volumes on paper or on screen. Rather, let's see. With a drawing, we can represent volumes various ways, using a vanishing point or perspective projection. This is a realistic representation useful for understanding the general aspect of the object. On the other hand, it's not very practical on the technical side. With an axonometric projection, we put aside the perspective and instead use parallel lines placed at precise angles, practical to judge the dimensions of the object. In oblique projection, easier to execute, the front view of the object is shown frontwards and sideways according to parallel oblique lines. The front face is directly measurable. Finally, multi-view orthogonal projections, the method that shows the object while providing the most technical information. That's why it's useful for manufacturing, as we've seen. After having been submitted to the planning department, the organization charged with the manufacturing study in an industry, the first step in the production phase, the drawings are reviewed and corrected, sometimes several times. Then, they're accompanied by documents that dictate, step by step, the instructions to follow to make and assemble the object. These documents are called the manufacturing process sheet and the assembly process sheet. They are all brought together to form what is called the technical file. The technical object during its lifespan, which is the time between its starting point, identification of a need, and its endpoint, recycling or disposal of the object, will go through several phases. As we have seen, first there is a design phase and a production phase, which will be followed by marketing and startup phases. Each of these phases includes steps within which technological languages are of great help to ensure the description of the object throughout its evolution. Let's quickly review the type of language associated to each stage. Finally, technological languages also serve when we analyze a technical object, that is, explaining what it's used for, how it works, how it's built, how it's mass-produced, and how it's repaired. It is thanks to technological languages that clients, designers, draftsmen, and business people can understand one another to creatively bring forth new technical objects.